Hi, good morning. Today we are going to discuss on the stress strain curve. What is stress? Normally we are thinking in daily routine life is stress is we are due to the work pressure that we are saying that stress. Similarly, civil engineering also called as the stresses in the stress internal resistance develops within the material subject to the external loads on the forces. The stresses are what is strain? The normal strain refers to the change in material to the original length. In the in this diagram, stress is strain. Yes, so that what is the stress diagram? In the experimental, you see y-axis is the nominal stress, x-axis shows the strain. You see, it is perpendicular to the normal and linear curve, and beyond that, on elastic limit, some deviation is there. You see, again, we will see that one. Now you see the elastic strain up to the elastic limit. It is the elastic limit. It is a linear manner. After that, it is the plastic limit. That is linear, then linear, then ultimate, and on. So that is the this one. You then the what is the stress strain curve? It is the tool understand the material behavior under the load. Stress strain curve help the engineer to select the right material to specific loading conditions in the words graph. The elastic region is the portions that responds to the elastic limit regains its the original position. Plastic region portions specimen begins the yielding limit and fracture limit and the maximum strength it is reaches. In stress strain diagram of concrete, and the concrete used for compression, why it is compression stress strain is major attention. The specimens obtained by the specimens at the 28 ages, that means curing of the concrete for the 28 days. That anticipated behavior of the concrete, we will examine that. The graphical representation, it is called as the stress strain curve. The produced concrete compression strain, it is shown in the figure. You see, as per IS 45669, stress is the y-axis and strain is this one. Zero maximum strain 2.2%. It is in the strain elastic limit. Beyond that, yielding plastic limit 0.0035. That's why concrete is the 0035 and steel is the Fy divided by 1.5. That is the factor of safety. The however changes in the nonlinear nonlinear concrete. That nonlinear means that inelastic limit. The elastic limit beyond the limit is called nonlinear concrete. The cracks will be formed. The change in temperature also it is called so the loads. So all these purposes, design purposes, we are taking for the compressive strength for these purposes. Hence, we have to avoid the overloads. We can calculate the factor of safety 1.5. The 0.67 FCK divided by 1.5, it will come the 0.45. The, as per the IS code of provisions, the earlier character strength given by the cube 150 by 150 cube, but the design entire structures compressive strength concrete would be produced in the influence of the soil in the figure. The IS code of provisions shown in the safety consider. Therefore, we already discussed on the 0.67. The FCK is rupture and middle is the 0.67 FCK. Factor of safety is 1.5. That is the 0.45 FCK. In Y direction, it is called as 0.002 FCK and 0.0035. next load of combinations we will see the next classes. Thank you. Thank you.